Okay, everybody, starting on number 7 from the review. This is just some basic, I guess, thought-provoking things about confidence intervals and kind of making sure that you really understand what would happen to the confidence intervals. So number 7, given the same sample statistics, so we're not changing anything about the sample, we're not changing the mean, the sample size, the standard deviation, we're not doing anything, but we are going to change the confidence level. So we've talked about this a few times before, and we even did the activity in class where we created our own confidence intervals. So I always like to think of it as starting with a base interval of 95%. So what's going to happen if we change our intervals to either 90 or 99%? So if we increase or decrease our interval. So here's the way I like to think about it. If you are less confident, okay, if you're less confident, what that means is we are not so sure the actual value is in our interval. So what that does, what that tells me is my interval gets smaller because now I'm suddenly not so sure that my true mean is somewhere inside that interval. Now, on the other hand, if I am more confident, I have to stretch the interval out wider to make sure that I've really captured the true mean or proportion, whatever it is I'm trying to find. So when we change our confidence level, as our confidence level increases, our interval should get wider, because if we are more confident that we have the true value, then we have to have a bigger interval to make sure it's really captured in there. Now, question 8, this one's a little bit different because this one wants to know what is going to happen when we alter the sample size. So we're not altering the confidence level, we're not altering the point estimate, all we're altering is the sample size. And kind of the general rule of thumb always is when you increase your sample size, you increase the effectiveness of whatever it is you're calculating. So anytime you can increase your sample size, that is good. So increasing your sample size, what is that going to do to your confidence interval? On one hand, you might think that it's going to make your confidence level go up, which might be true, but don't get that confused with confidence level going up, meaning you have a wider interval. So in this, your confidence level is staying the same. So let's look at, we have a 95% confidence interval where n is small. Now we're going to have a 95% confidence interval, but we're going to make n a very large number. We're going to increase our sample size. So what that's going to do, how that's going to have a good effect on us, is that's going to actually shrink our confidence interval down. And with a larger sample size, we can be a little more sure that we have the mean in there, and we can actually close in on it a little bit more. So what's going to happen is the width will decrease as n increases. Alright, so now back to some examples. You wish to estimate the miles per gallon of a car's luxury sedan. You collect a simple random sample of 35 and you find a sample mean, so an x bar of 19.2, sample standard deviation of 4.9, so that's S. So right off the bat, I notice I do not have a population standard deviation. So that tells me I'm going to use a t interval. So on my calculator, I'm going to go to stat test t interval. So sample mean of 19.2, standard deviation of 4.9, sample size of 35, confidence level 95. So I have a confidence level of, confidence interval of 17.5 to 20.9. So we are 95% confident that the true mean miles per gallon is between 17.5 and 20.5. So how large of a sample would be needed to cut the margin of error in half? So what that means is we're going to have to actually know what the original margin of error was in our first problem. So knowing that the point estimate is right in the middle, I can get a pretty good idea of my margin of error just by doing some subtraction. So I'm trying to find that wiggle room, and I just want to show you that both are going to be the same. So if I go from my point estimate down, it's minus 1.7. If I go from my point estimate up, it's plus 1.7. So up here, I had a margin of error of plus or minus 1.7. Now they want us to cut that in half, so that means I want a margin of error of plus or minus 0.85 miles per gallon. So you are going to have to use the formula and do this one by hand. So it's really nice that the calculator gives us the confidence interval so easily, but we still need to know the formula. So here we're going to have to do our T critical times S divided by the square root of N. So I need to replace margin of error with 0.85. I need to calculate my T critical, so I'm going to go to second vars, inverse T. This is what, 95%, so it's going to be 2.5% for my area to the left. My degrees of freedom, oh, I'm not going to know. Hang on.